Hello, in this video I will be discussing how you go about determining the lifting condensation level, or basically the cloud base, given atmospheric conditions. Alright, so if you start looking at this, let me go ahead and get my draw tool up here. Here's some things that you actually have to look at, and you have to have initial information. Some of the initial information down here is that the temperature is 25 at position A, so that's right through here, so that's our sea level temperature. And then the temperature at the condensation point is 15. Okay, so whenever you look at this, here's what you're kind of, you're kind of looking at and saying, all right, under what conditions will I get this? So right here we have 25. 25 is there, and that's really what we're given. Well, if you go up, every time you go up 1,000 meters, which would be position B, position C, each one is set at 1,000 meters, we know that the actual temperature decreases by 10. That right there is what is called the dry adiabatic rate. Okay, so we know that right here the temperature is going to be 15. Well, there's where we've got to stop, because what ends up happening is the actual the dew point temperature right there. So now we know that the cloud base is exactly 1 kilometer. So that means that the dew point at the surface was 17. Okay, and so there's how we go about getting the lifting condensation level, or the cloud base. So that right there is the LCL. Okay, so the LCL is 1,000 meters. Now, after you do this, after it reaches its dew point, what ends up happening is you then have to switch over to what is known as the wet adiabatic rate. That's because the air is no longer lifting as dry, because the temperature and the dew point are equivalent. So now you've got to switch over. So that means that the temperature up here is going to drop by 5 degrees instead of by 10. So that right there is going to be 10 degrees, and then of course 5 degrees. Okay, now up here this stays the same right through there, and so that's what you're looking at there, because the air is continuing to be wet. Now, what happens on the downward side, or on the leeward side of the actual mountain? So as this air descends, what ends up happening is it depends on what you're actually being told. Is the air descending wet, or is the air descending dry? So what we'll do is we'll look at what's happening to the air in a dry condition, and then I'll show you what it's like in a wet condition. Okay, so if the air is completely dry on its descent, that means we go back to the dry adiabatic rate, which is 10. But instead of decreasing, now the temperature increases. So that'll be 15, 25, and then 35. And then on this one, it goes 7, 9, 11. Okay, and so now what you end up seeing is you end up seeing that look how dry the air is on that side, 35 and 11, as compared to how wet it was over here. It's not completely wet, but I will tell you it has a high relative humidity, and that's based on the temperature and the dew point being close together. Since the temperature and the dew point are far apart over here, that indicates that that air is exceptionally dry, and that is called a rain shadow. Okay, now if I said that this air was wet on its descent for 1 kilometer, that means that it's going to decrease, and it's going to go back to the wet adiabatic rate, which in this case is 5. So that would be 10 right there. But then what ends up happening is now we go back to this, so that would be 20, and that would be 30. Because I said it only decreased for 1, so that's how you go about looking at that. Okay, and this doesn't need the mountain to be the instance either. You can do this with any parcel of air whatsoever. And so that's how you go about solving for the lifting condensation level, and you're able to determine what happens on the other side. You have to look at the dry adiabatic rate, and then once the air becomes saturated, which is when the temperature and the dew point are together, then you switch over to the wet adiabatic rate. Okay, so hopefully this video has helped you out in explaining how you go about determining the LCL and temperatures at specific levels.